So now let's start talking a little bit about solubility. Okay, what does the term solubility mean? Okay, when a substance becomes dissolved in another substance, like an ionic substance will dissolve and dissociate in water. So when something is actually dissolved, we say that it is soluble. When we put something as solid into water normally and it does not dissolve, we say that it's insoluble. So when we're looking at ionic compounds, normally ionic compounds will dissolve in water. We usually say that covalent compounds do not dissolve in water. So when ionic compounds dissolve, we say that they are in a dissociated. They dissociate in water. They break up into their ions. So when we have lithium, not lithium, but sodium chloride, say we have sodium chloride and we put it in water, just salt, we put salt in the water, it dissolves. So we say that it dissociates. So basically what you have is you have little sodiums, ions, and chlorine ions floating around in that water. They disassociate, they break up, and that is why they dissolve. And that's what we mean when we say that they are soluble. If they stay together, then we say that they're insoluble. So, how do the solubility rules work? Soluble compounds stay in aqueous form. So basically, if something is soluble and we're looking at it, it stays in its aqueous form. It's soluble. We don't see anything floating in the liquid. When it's insoluble, it precipitates out into a solid and falls out of solution. So basically, something that's soluble, we say that we don't see anything floating in it. If it's insoluble, we kind of see stuff floating around in the water. Okay, famous quote: "If you're not part of the solution, you're part of the precipitate." So that's what we mean. The precipitate. If you're not in the solution, then you precipitate out and you become that solid that sits on the bottom that kind of floats around in there. Okay, what are the solubility rules? Now, the way we predict in a double replacement reaction if there's going to be a solute, or it's going to, not a solute, but there's going to be a precipitate. The way we do that is we look at the solubility rules, and these are on your star charts that you should have. And we see the solubility rules tell us what is soluble and what is insoluble. So here are just some rules. Everything on this top part, it's soluble compounds containing. So it could have anything, and we're really looking at the anion. What is it that metal bonded to? Because we're looking at these for ionic compounds. And basically, if it's bonded to one of those things, so if anything's bonded to nitrate or our chlorate or hyperchlorate, any of those guys, it's always going to be soluble. Okay, we can see that we do have some exceptions. So if it's an exception to being soluble, it then becomes insoluble. Okay, down here we see that we have some insoluble compounds. Those contain, and it has these anions right here. Okay, so anything bonded to this is going to be insoluble. That means it's going to form a precipitate. Okay, there are exceptions. If it's an exception to being insoluble, then therefore it is soluble. So let's look at the two that we have right here beside us. We say that lithium phosphate is soluble. Okay, so we look and we find, what is lithium bonded to? Well, it's phosphate. We find phosphate, it's right here. It's in the insoluble list, but there's an exception. Compounds containing ammonia and alkaline metal cations. So lithium is an alkaline metal, so it's an exception to being insoluble, so therefore it's now soluble. We have our calcium phosphate, which it says it's insoluble. Okay, there's phosphate, that's what it's bonded to. The exceptions are ammonia and alkaline metal cations. So this is an alkaline earth metal, so it's not ammonia, it's not the other exception, the alkaline metals, so therefore it is insoluble. So when we're looking at this, how can solubility rules help us predict double replacement reactions? What this boils down to is that if there's no precipitate, there is really no reaction. All ions are still in the dissociated form. So basically what this means is that if there's no precipitate that forms, we don't actually have a reaction. All they're doing is they're just kind of floating around in solution. They're floating around their dissociated forms, what they break up into. So if there's no precipitate, are they there? Yeah. Does anything happen? No, not really. It's not really a chemical reaction. Not a new product is being formed. Now, if there is a precipitate that forms, so that solid that falls out of solution, there has been a double replacement reaction, and that cation and the anion precipitate out of solution. We see that solid. So no precipitate, no reaction. If we see a precipitate, it's a double replacement reaction. So some examples. It says predict if a reaction between silver nitrate and zinc chloride would produce a precipitate. So we have silver nitrate. So we have to write out their formulas. Silver nitrate, we have Ag, and the nitrate is NO3. So silver is always plus 1, nitrate negative 1. We crisscross, and we get our AgNO3. Okay, that's our first compound. Then we have our zinc chloride. So our zinc bonded to our chlorine. Zinc is going to be plus 2, chlorine's minus 1. We crisscross and we get ZnCl2. Okay, when we're looking at this, we take this other compound up here, and basically what we're saying is that we're putting them together in an aqueous form. We're putting them together with water. So look, what's supposed to happen is a double replacement reaction. So silver is now going to be bonded to chlorine, which they both have plus 1 oxidation numbers. So what we'll see is we'll have AgCl plus 1 minus 1 crisscross, and we get our AgCl. So we look, if there's a solid, if this is insoluble, then we have something that precipitates out. So we look at it and we see that we have chlorine. There it is. That's what silver's bonded to right there. And then we see, are there any exceptions to it? Because it is soluble, so there shouldn't be a solid. But let's look at the exceptions. It says a compound of, we have our silver. So silver chloride, since chlorine's bonded to silver, this will be a solid. So that is a precipitate. The other thing that we could possibly have, let's see what zinc does. Zinc, which is plus 2, is bonded to nitrate, negative 1, crisscross, and we get ZnNO3 2. That's our other compound. So those are the two that we have. What is it bonded to? It's bonded to nitrate. Look at nitrate. There it is. Does it have any exceptions? No. So this is aqueous. So that will stay in solution, and that silver chloride will fall out of solution. That is a solid, so therefore there's a precipitate. Double replacement reaction actually has occurred. Next example. We see that we have our calcium carbonate and ammonium chloride. So calcium carbonate, we have our CaCO3. Ca is plus 2, carbonate negative 2, crisscross, and we get our, since they're both 2 and 2 ratio is a 1 to 1, so CaCO3 plus our ammonium chloride. So ammonium, okay, we know what that is. It's a polyatomic. It's NH4 with a positive 1 charge. Chlorine, negative 1, crisscross, and we get NH4Cl. Okay, what are the possible products that we could have? Okay, the possible products is calcium bonded and switches places, and it's now bonded to chlorine. So CaCl plus 2 minus 1 crisscross, CaCl2. Okay. Plus the other possible product that we could have is we have our ammonia, which is NH4 plus, and then our carbonate CO3 negative 2 crisscross, and we get our, we'll zoom in right here, NH4 2CO3. So let's look at if a reaction is actually taking place. So in our first possible product, we see that it's bonded to chlorine. Calcium bonded to chlorine. Well, where's chlorine? Chlorine's right there. Okay, the only exceptions that it has, compounds containing silver, lead, or mercury. It's bonded to calcium, which is none of those. So this is going to be aqueous, stays in solution. Okay, our next possible product, we see that we have carbonate. Well, where's carbonate? Carbonate's right here. The only exceptions that we have, it's insoluble, so therefore it would form a solid unless, well, we see that it's bonded to the compound of ammonia, so that would be aqueous as well. So therefore no reaction has actually occurred on that example because they're both aqueous. They're both dissolved. Our last one that we see that we have our magnesium nitrate and our potassium, and that should be our hyperchlorate, okay, or perchlorate. So we see these. Let's write our possible products. Magnesium switches and now it's bonded to chlorate, plus 2 ClO4 -1 crisscross, and we get our MgClO4 2 plus the other possible product that we could have is now potassium. It's bonded to that nitrate, so K, which is +1, NO3, which is -1, crisscross, and we get KNO3. So let's look and see if a reaction has actually taken place. So our first one, magnesium perchlorate. So we find ClO4. There's no exception to it. It is soluble, so therefore it is aqueous. So that's not a solid. And we see that we have nitrate and nitrate right there, and none. So therefore that is aqueous as well. So therefore there's no reaction because there's no solid compound that's formed.